We will start our session in next 5 minutes after a few participants will join the session.
Okay.
So before that, Muskan, do you have any doubt or anything that you want to know?
No doubt.
Okay. So do you like have you registered for this final examination?
Yes,
For
I
this?
have registered.
Okay, okay, fine. So in the final examination, similar kind of questions you should prepare, and uh, yeah, you hope you will score a good scores and get good certificates from their NPTEL. So they have different categories like gold, diamond, and something like that, silver. So all thing like you attend the examination, if you score certain you can say grades, so you'll get this kind of certificate.
How
That's
many questions are there gonna be? Like
50 to 60 questions, I think.
for 3 hours?
Yes, yes. So it will be
Okay.
sufficient. This time will be sufficient for you. There's no issue of time. You just need to read the question. The questions are similar to this, like what we are discussing in the sessions, and what is there in the assignment, right? So while solving your assignment, the 10 question you just need 10 minutes. I think 1 minute is sufficient for solving one question, right? So all are
Yes.
theoretical. Maybe one or two numerical you will get that we have discussed. So that to be very simple and not simple, but yeah, that to be the question will be tricky, but that if you solve it, it will be a very simple calculations. Okay, so it's like that. So there is no issue with time. There's no worry with time. Okay, don't worry. Uh, but yeah, you have to attend the examination sincerely, and that's all. And I hope you're submitting all the assignments on.
Yes, yes, I am submitting.
Okay, and you're getting the good grades, right? Yeah,
Yes.
that's fine. So in that also, if one or two assignments you missed it or you didn't got good grades, so you do not need to worry because only top 8 assignments out of 12 will be counted. Okay,
Okay, okay.
that's fine.
They are all MCQ based, right? The
Yeah,
final
yeah, yeah,
exam will
yeah,
be.
yeah, yeah, yeah. Same pattern will be
Okay.
followed. So today only in the live session, I think you are present. So that professors have told that the question will be same. It will be like so question will be similar. The objective type question will be there with four choices. Maybe there will be in some question only two choices, like two choices for the true and false type of questions.
Yes,
So
yes,
two
understood.
choices, yeah, and then there will be four choices, and uh, you have to choose the best option from there.
Yes, understand.
So currently, what like which course you are pursuing?
I'm actually doing B in printing and packaging,
Okay,
and this is my fourth year. So
okay,
actually, this last sem is the internship. So I'm
okay, okay,
actually doing an internship at Eton,
okay.
Pune.
Okay, in Eton Pune you are there.
Yeah.
Okay, okay. My few friends are there in Eton Pune, right?
Okay.
So I don't know, like you guys have different divisions.
Yeah, yeah, yeah. I'm actually
Hmm.
in logistics.
Logistics. Okay.
Yeah,
Yeah.
supply chain management.
Okay, okay, okay. So some of them are in power controls, and
Okay.
some are this R&D section. So basically, my friends are there in R&D section.
Okay. There are basically like three locations in Pune.
Okay. So
So
Magarpatta is
okay, okay.
something.
Yeah, I visited there once,
Mhm.
but I'm actually in some different location.
Okay, okay, okay. So these my friends are there in Magarpatta. They used to
Okay,
say.
okay.
I haven't visited Pune, but yeah, they used to say this.
Like they have this innovation center there. I recently visited
Mhm.
that. They have various testing labs over there.
Yes, 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 yes. They used
Yeah.
to do R&D activities only. They are there.
Yeah. Okay.
Okay, so I will start the session. Hello, everyone. I welcome you all to the today's live session. This is a ninth session that we are taking for product design and manufacturing. I'm Surit Anand Singh. I'm PMRF Fellow in the Department of Mechanical Engineering, Indian Institute of Technology, Jodhpur. And I got this opportunity from PMRF NPTEL TA scheme to interact with you to take these classes, this live session, to solve your queries related to the this particular course, which is offered by NPTEL under the course code of NOC 23 ME14. So there was a live session from instructor also. It was scheduled today. I hope some of you have joined and maybe some of you have missed it. So instructor were like the Professor J. Ram Kumar and Dr. Amal A. Singh was there. So uh, they were there to answer your queries and all. Uh, yeah. In this session, we used to go with, first of all, we discuss a few questions which are similar to the assignment problems, and uh, that is also similar to the examination pattern, the question that will come to your to the final examination, and later we'll take some questions from the discussion forum, and then the session will be open for the questions or queries that you have. So last time there were certain technical glitches because I was using some different system. So it was like glitches in terms of like presenting the screen and all. So this time, the last time we just what I said, I have prepared something for this 3D printing and all. So again in this week, the course content of what you can say week 10, in that week 10 you must have seen the demonstration video, right? So there was a two long video of 40 minutes where you have seen the each and every aspect of 3D printing, actually how 3D print, like from starting how to make the model and then how to feed the model to the to a 3D print additive manufacturing machine, that and then how to perform certain operations, and then load the job, and then perform the 3D printing, and then how to extract the, like how to set that machine and everything. It was clearly and very elaborately discussed in those two demonstration video. So if you haven't seen that, I just recommend you to go and see those two videos. They are very helpful for, they'll be very helpful for you to gain the understanding about the additive manufacturing. If you have not seen the machine, this additive manufacturing or 3D printing, 3D printer, so you will see there how they work and how, like one type of 3D printer is there, FDM. So how it work and how the components are get printed, how to perform that prototyping is done with the help of that. Right. So starting, I will start this session with the present this with the presentation last time where we left. Okay, so I'm going to show you some glimpse or what you can say some brief idea about the 3D that additive manufacturing 3D printing, and then we'll go with the questions and other thing. So so yeah, these are the basic outline that I'm going to cover about the additive manufacturing. So we'll see about the basics of additive manufacturing 3D printing, then we'll see what is FDM, that is very common, and that is like fuse deposition modeling. So these kind of printers are very much common and they are very popular. Then we'll see about SLA, and then what are the current trends, and we'll show some what how the research is, or what is the uh, current market of 3D printing. So so the first is the steps involved in additive manufacturing. So first of all, we have to prepare a CAD model. So for preparing the CAD model, you can use any of the CAD drafting software, including SolidWorks, Creo, uh, AutoCAD, or something like that, or Fusion 360. Okay, if you are using online tool, you can use GrabCAD. This OnShape. Okay, so OnShape is one of the online drafting uh, website, or you can say what you can say software. Okay, which host this CAD tools. From there, like that CAD model can also be get from some this scans. Okay, so if you have any component and if you want to do the reverse engineering task, so you can scan that component in the 3D model. Okay, and you can process that. So with the help of 3D scanning, so there are different kind of scanners that are available, like blue light and white light scanners. Okay, so they are laser based scanner. They used to scan the component and create the uh, create the same part. Okay, so it is like reverse engineering kind of thing. If you have like suppose this is a component that you have, and you have to get the 3D model of this. So you do not need to do much thing, just scan it in the that scanner, and you will get the 3D structure of this particular thing. Okay, then from there we have to create a touchlation model. Okay, so like there's a file format to save that particular CAD model. So those models are like those models are saved in particular formats. Okay, so here for 3D printing we have to it is highly like it is only required to tessellate the model and save that model in .stl file. Okay, so the file with .stl extension is only like standardized for usage in the 3D printing. So why only that? Because the slicing of we have to do the slicing of that particular model. Okay, so because this additive manufacturing is a layer by layer manufacturing. Okay, so we first deposit one layer, then over that we have to deposit another layer, and so is it done by CAD software like CAD? Yes, yes, yes. In any software, you just go for like when you go to save the model, by default it is something like dot obj or something like that. But once you see that save as option, you will find that the format is there. Dot stl format is always there in any of the CAD tool. Okay, in CATIA also it is there. So from there, after that, we slice this model. Okay, so this slicing is done in the software, which is with the what you can say this and that printer. So the slicing is performed. Okay, so we perform this slicing operation. So why slicing? Because we have to get the tool path for that. Okay, like path for the deposition. So it is a layer by layer. What I said, layer by layer deposition. So just like one layer is completed, over that another layer we have to fix, then another layer. Okay, so this by layer manufacturing is the additive manufacturing only. So then after slicing, it is passed to the like the job is created to the printer, and it is start printing the component. Okay, so this is the overall steps that are involved in any of the additive manufacturing process. Okay, then after that we have to do like after 3D printing or after doing the additive manufacturing, we have to do some post processing for final like finishing processes, some other finishing process, like we have to remove the support material, we have to remove the if there is some disparity or if there is some problem with the printed part. Okay, sometime like this extra threads are there and extra material may be deposited, so we just do some small finishing operation. Okay, so to produce the final part, so that is very minimal task. Sometime if the printer is very high end printer, you do not need to do all these activities also. But yeah, for making the prototype or the component very perfect, we used to do some post processing of the final product. Okay, next so what I said, it is a layer by layer manufacturing process. So suppose if you have to manufacture, someone has raised hand. Okay, so if you have to manufacture a component which is hollow structure, okay, or what I say, which kind of structure? So let me show you. So suppose if you have to if you have to print 3D print this, okay. So you can see this is a like smaller diameter. This feature having a smaller diameter. This is having more diameter. Okay, larger diameter. Then there is a hole here. Okay, this hole, there's a hole here. So if you go for 3D printing and
Sir,
then
I think, sir, we are on your slide. We are you showing some cursor or something? Huh.
yes, yes, yes.
Yeah, it was not visible, sir. It was a plain slide.
Okay, now it
Yeah.
is there.
No, we still cannot see the cursor, sir.
No, no, on not on cursor. I'm showing in the video, like my
No, no,
video.
sir. We are still seeing the slide, sir. That's the problem. So I think you have to share the screen rather than app.
Okay,
So
okay.
the video is visible.
Video is visible, right? So,
Yes.
Nikhil, you have to pin right in the
Okay.
this pro the people who are visible. Just see me. Am I my video is visible there or not? Like you have pinned the slide one. Like two of my profile is there. One is which is the
Oh,
PPT. You have pinned that, so it is only on the screen. Next is my video. So just unpin that so that it will automatically change when I like from the PPT to my video.
okay.
So there's a pin option. Pin
Yes, 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 yes,
not
yes.
as visible.
Yes, sir. So now I can see the flask you are
Ah,
showing.
yes, yes, yes. So
Can
yeah.
you please repeat, sir? Sorry.
So yeah. So like you see like how there are certain features here, right? So one feature is here. So it is having a small diameter. Okay. Then another feature is here. It is having larger diameter than this. Okay. And then these are the holes. Okay. Let's see. These are visible.
Yes, sir.
This is a hole and then there
Yes,
is
yes, visible.
okay, okay. So if you make a like CAD model for this and then pass it to additive manufacturing machine or like 3D printer, so it will start printing. So suppose it, like what I said, it is a layer by layer manufacturing. Okay, so it will first print this particular layer. Okay, this layer it will print, then over that it will print another layer, because we have sliced it. Okay, so once it come here, then there is a whole overhanging part. Okay,
Hmm.
this is the overhanging part. So if something is like that, there is it is just like a nozzle.
Hmm.
Something we are dropping from the nozzle and it is getting on a surface and it is
Hmm.
getting deposited. But here there is no base. Okay, there
Hmm.
is no base. So it will again drop at this level. Okay, this bottom level, and it will start depositing the model here only. So how to like how it but it like when we do in 3D like that additive manufacturing, this is not happen. So what happened here, so this is the there are two kind of material in the any printer. One is the support material and one is the another is the that main material. Okay, the material of the component that we are material which we are going to use for manufacturing our component. So at this part, like where there is support required. Okay, so here
Hmm.
what we required
Support.
some support up to this level. Okay, the final level of this this particular this structure. Okay, this smaller diameter shape. So up to here, this part will be like support structure will be printed. Like support structure will be printed there. Okay, so when you see the printing of this, so you'll find that outer circle will be with the support structure and inner circle will be the main material. Okay, up to certain height. Then main material will come into action and then main material will print. Okay, so later on we'll remove that support material and we'll get this kind of shape, right? So do you got like what I'm explaining, how it happens in the 3D printer? Or is there any confusion still remaining? Hello.
No confusion, sir.
Okay. So same thing, same problem will happen here. This part. Okay. Again, we are depositing at this layer. Okay. So what will happen after depositing at this like at this height? Okay. There is some hollow structure. Okay. So like it will how you will go to print this? If again you will go like nozzle will come here, it will drop the material down because there is a hollow structure. Okay, so for this also the support material will be here. It will filled with the support material. Okay, and then the main material will come here, and later on we'll remove the support material, right? So this
How how will we remove that circle, like the support material?
so the support material is very like you can break it. Okay, with the help
Okay.
of some tool, you can break it. Okay, it will be it is not going to be stick with the main material. It is a very what you can say in a mesh kind of a structure. Okay,
Yes.
and very just for support. Okay, so it
Mhm.
is like a what you can say. It is not edge must edge.
Strength wise, no?
Yeah, yeah, strength wise. So it will be very what you can say.
Porous kind of
Yeah, porous kind of
powder
structure.
kind.
So
Sir,
you
and
can
we can reuse it also, no? Again for the next.
no. So
So that will be a wastage.
that will be a wastage. Like people
Okay.
are what nowadays research is going on to reutilize that. Okay,
Hmm.
so like in IT Gandhinagar, one of my friend is there. He's going to reutilize that. Like he's building some technique so that the all the wastage, like in 3D printing, the wastage in terms of the support material is very high. Okay, so
Hmm.
they are planning something so that this support material should be recycled and then again used for another printing operation or something like that.
Ideally, sir, support material can be something like which is not very costly, like
Ha ha
even sand kind of sand or
ha ha
something,
ha
so
ha.
that even if it's wasted.
Yeah. So people are doing some research in this
Okay.
field. So while making this structure, the civil architectures for like chairs, tables, and recently there is a news of the people this researchers from IIT Guwahati. Again, he's one of my junior. So they have what you can say incubated from IT Guwahati. Is again pursuing his master this PhD from there. So he with his friend and some other faculty members. So they have built the concrete structure. Okay, so there they have used some this sand kind of thing for support material in those kind of applications. Rest for this ABS, people use that plastic only. Low cost plastics are there, like ABS materials are there. So for that, support structures are required. Okay, so here in the figure also you can see. So if you have to print this kind of there's a overhanging parts. So this green parts are the support structures or support materials are deposited there. Okay, so here you can see when you are making model for home. Okay, so for window, for these pillars. Okay, so these green material are the support material that is printed, and rest are the final original materials.
That support materials needs to be removed just
Yes,
after, or like after that it cools, no? It is not easy to remove.
yes. So like once the part is completed, okay. So after taking the part out, you can just remove it. Like it become difficult later on because it gets solidify. Okay, but yeah, there are certain tools which are supplied with the that machine only. Okay, some certain tools, that some similar tool that people use for pedicure manicure. Okay, so those small instruments are there, so you have to just do extra effort, like do extra work for removing that, but yeah, it definitely get removed. Okay.
Okay. Okay.
uh, so this kind of a structure is initially printed, and then later on we just remove this. We just remove this kind of structure. These are the support structures. Okay, so we just break it and then find like rub it with the tools that we have, and then we get the final product. Okay. Next, there's a slicing process. Similar slicing process you can see at your home. Like suppose you take a potato and then chop it. Okay, so similar kind of slicing process is this software do with the CAD model. Okay, that we supply. So we provide the CAD model and they slice it in layer. Okay, and then the layers are like there's a CAD model, and then it is sliced from here, like one slice, two slice, like it this slicing is very small. Okay, so this gap between this slicing is very small. Okay, this gap, I'm talking about this gap, so it is very small, but it is sliced in certain what you can say uh, slices, and then automatically the software take the path, like note down the path where it has to deposit the material, and then it is the sliced model is sent to the printer. Okay, so before sending it to printer, the softwares are capable of estimating the time, estimating the material. Okay, like what material, like how much support material is required, how much main materials are required, and like this. Okay, and then weight estimation and everything should be done. Then like we have to calculate the number of layers and thickness of the layer. Okay, so more fine layers, so the appearance of the object or the material will be of the component will be high. Okay, and then we required more precise printer for that. So based on the application, we used to choose the layer thickness. It depends. Okay, and then based on time also, like if we want to just complete the part as early as possible, so we have to increase the thickness of slicing. Then after that we have to post process of the component. Okay, so this is the post processing. So this is the final, what you can say, the 3D printed component that you get, and then this is the processed component. Okay, so you can see certain finishing operation has been performed over it, and then polishing and everything has been done, like painting and everything. So it look like this. Okay, so this transformation we have to do as per like requirement. Every time it is not required, sometime, but yeah, sometime if we are going to this use at this as a final product, this 3D printed component as a final product, then you have to do some post processing. Otherwise, it is, if it is only for prototyping, then it is fine. Then this 3D printed part is only fine, right? Next, the very popular FDM technique, fuse deposition modeling. Okay, so in this fuse deposition modeling, this is a type of additive manufacturing technique. So most of the printer, if you find and if you search for on the internet, on the Google, so you will find this kind of printer in like less than 30,000, or maybe more less than like less than 20,000 only. Okay, so those are FDM printers. Okay, they use the this material in form of reel. Okay, so reels of this ABS material. Okay, this plastics, kind of plastics. Okay, and then it is feed to the nozzle. So before the nozzle there is a heater. Okay, so this band heater is there which heats that material. Okay, and up to what temperature we have to heat that material?
Melting point.
So like it is like 0.5 degrees Celsius more than melting point. Okay,
Okay.
so
Okay.
0.5 degrees Celsius more than melting point. Why 0.5 degree more? Because like if
Free
It
flow.
should be in molten state so that
yeah,
it
yeah,
is
yeah.
easily able to construct it,
Yes,
like
yes,
Correct.
yes.
Free
Yeah.
flow.
So
layers.
yeah. So because after coming from here, it not instantly get like after coming from nozzle, it does not instantly get cooled. Okay, so it comes in the zone of melting temperature after here, because it has to pass from, like band heaters are here, and then it has to travel this distance, right? So we have to give some extra heat to it so that the cooling process uh, take like this extra heat. Okay. Then yeah, so on the there's a base plate also in the every printer, so that the base plate, standard base plate over this material, over which this material is going to deposit, and it is the property of that base material, it does not stick with that. Okay, this material do not get stick with that base material. Okay, so in some printers what happened, first of all, to solve this issue of sticking of the original material with the base material, first of all, one layer of a support material. Okay, so the very fine layer, very porous layer of support material is deposited, and then over that the model is start building. Okay, so that it is easy to break, easy to separate that base plate and the fabricated or the 3D printed 3D printed component from the base plate. Okay, so this FDM is very popular, and this is a typical structure. Okay, so in India, there are a lot of researchers who have made their own kind of what you can say, this kind of FDM printers. Okay, some have used pellets. Okay, so the what they have did. So in spite of uh, providing the material in form of coil of this, uh, they created material in form of pellets. Okay, small balls. Okay, very small balls of this material. Okay, so we call it is called as pellets. Okay, and then they feed the pellet into the hopper. So there is a hopper kind of a structure, and then again there is a heater. So this heater melt those pellet balls, and then the same deposition process is performed. Okay, so there are lots of people who do this kind of research, and they used to play with the material, the property of the material. Okay, and this kind of thing. So
So instead of filament, they are putting ball kinds of structures,
yeah,
spherical.
yeah.
Okay, okay, okay.
So ball kind of pellets, you can say,
Okay.
it's very tiny, tiny particle of the
Hmm.
plastic or the material.
Correct,
Okay,
correct.
so sometimes they used to now it is popular, so it comes in the it is available in the market, commercially
Hmm.
available in the market. But suppose sometime if you want to print some specific material with your property, like the property that you wanted. Okay, so you have to you can make it like that. Okay, yeah, mix some powders, and then melt it, and then make it in form of like pellets, small, like you can cut it.
Okay.
It basically looks like sabudana, like small
Yes, yes,
pellets.
yes,
Yeah, yeah.
yes. Sabudana, only sabudana. Okay, so that sabudana is that kind of small balls are there. So they that same of any material you can prepare and then feed it to hopper and then print it. Okay, and then perform the testing and everything. Next is yeah. So this kind of structures are printed with the help of this FDM printer. Okay, so I have one structure I can show you. Okay. So these all are the parts that we have printed with the help of the 3D printer that we have. Okay, so this is a one. Then this kind of bell you can see. Okay, so for this inside there was the base, that support
Support.
material. Yeah, and
Okay.
then this, and yeah, so these are all the components that are printed for demonstration of the laboratory of additive manufacturing to the this undergraduate students. Okay, so this you can print. So there's a keychain kind of thing, you can say, with the roll number of the student. Okay, last
Hmm.
two roll number of the student, they have to, these are the tasks which are given to the students. Okay, to print it. And
Sir, the
one very
support is printed by nozzle too, kya?
yeah. So in some printers there are two nozzles. Some printers have one nozzle, and then there is a feature of transferring that material, that
Okay.
what you can say, that support material. So
Okay.
what happens? So when there is a command for support material, so that support material line comes to the hopper, and then
Hmm.
if there is a command for base material, so base material line comes. And most of the printer have two
Maybe
two
it will have thickness difference, no? Otherwise, if it is the same material. It will
Yeah,
just
yeah,
have thickness
yeah. So
difference.
this kind of this is the another what you can say. These are the research that I have seen in the additive manufacturing. So initially this was there, and then what Muskan said, that nowadays people used to print the same material with different density. So if the material costing is very less, so we can use this kind of technique. Only one material for the support material, we print we use the fine we use the chorus layers. Okay, so having more gaps, and for the base material as a base material, we use it very fine. Okay, so the layers are so very fine layers, and very minimal gap will be there. And this for support material, the same material is used, and but the printing will be done like in a chorus form. Okay, so one more thing that I wanted to share is, like, suppose if I got this component to print. Okay, so this is the component. Okay, you can see with in this view. Okay, you can see there is a extra, like this is the extra part. And if I will print it like this. Okay, if I print it like this, so I will need more support material at this part, right? Are you following me?
Yes, yes.
Yes.
Yes, sir.
Yeah, so what we have to do, we have to change the orientation of printing also, and that we can do. So
Yeah.
based on the optimization. So this is the basically optimization. So based on that,
Reverse it.
so
Reverse it.
Yeah,
we can
reverse it.
print it. Yeah, we can
Mhm.
print it like that, so that we don't have to waste our that base material, support material.
Support
In
material.
fact, in this, you won't need a support at all, right? In
So
this.
yeah.
If
In
you
this
do it
orientation,
reverse, there will be zero support required.
so if it is like that, this position, so we need support. Okay,
Yeah,
if it is like that, we don't need any support. Okay,
correct.
so this kind of optimization is performed during, like, before sending the job to the printing. Okay, so this can be done manually, and this software can also suggest us the proper orientation for that. Okay, now one more thing. Suppose this kind of structure. So suppose there is no feature. This is just a rod. This cubical rod, it is there. Okay, so if we have to print it. Okay, so we one is like we can do the printing in this orientation, another is in this orientation. So which orientation you will prefer?
Horizontal orientation.
This
Horizontal.
orientation.
Yes,
Yeah,
yes.
yeah, because like here comes the mechanics. So if we print it like this, so it there is a chances of bending this structure. Okay, because it is getting deposited, and maybe there will be some load, like while cooling.
While printing, yeah.
Yeah, like after printing, there's like cooling of the cooling of that material will be happen. So if it is non-uniform, so it will be like this, and then again it will take like printing this layer layer by layer. So then slices, number of slices are different. Okay, so it will be
It will
now
consume more
it
time
will
also.
no, like not in terms of time, in terms of strength. So like if you're cutting in, like you have to slice it like
Yes,
this.
yes.
Okay, and if you're printing it like this, you have to slice it like this. So here you have to slice it like in maybe 10
More
parts. Here,
layers. Yeah.
you will be done with two or three layers. Like not two, three,
Yeah,
maybe
yeah. Understand.
20 and 100. Okay,
Yeah.
so this will be the ratio. So this is the thing, and then based on the application of the component that you are going to use. Now, suppose the same cube you have to use for compressive, like you have to place it for some compressive load. Okay, so at this two end, the loads are applied. So if you print this component in this horizontal with horizontal view, this like in horizontal orientation, then it will easily break in the compressive because it is having less compressive strength. Okay,
Yes, according to the strands of the orientation.
yes. So accordingly, like we have to select the orientation as per the applications also. Okay. So if it is going for this tensile testing. Okay. So if it is going for some tension. Okay. Tensile load at the end. So we will not definitely we will not print in this orientation. We have to print in this orientation. But if it is going for compressive some compressive load, so we do not print in this orientation. We have to print it in this orientation. So these all are the what you can say, process optimization research that that people used to do, and then perform this uh, prototyping and manufacturing of this components, right? So I hope you are getting some more insights about additive manufacturing with all this. Okay, that we are spending more time here. Next is, like, you can see lots of components we can print it. Maybe it is like a model of wind turbine, some model of this 3D Greeks and all, and then customized gifting purpose also. So this customized gifting is one of the very what you can say, we have a recent, like, we have printed. And during COVID time, when there was COVID, so the college were not able to host the, what you can say, convocation, okay, to giving the degrees to their student. So in my college, we have made a sample for that gifting. Okay, so in that there's a photo of our director giving a degree to the to the photo of the student. Okay, and the face of the student was taken from the picture, their original picture. So it is printed, and after printing, we put a light back at the backside of this structure. Okay, it was very similar. I don't have right now with me. Okay, so this, like this only. Okay, so from photo we have created the 3D model and then printed it, and then after placing light behind it, it glows. Okay, so it was a very unique what you can, kind of thing that we shown, and then it was given the, like, there's a 3D manufacturers are there. So because the order was in bulk, so the order was given to prepare, like, for all the students. And this was a gifting idea which we have got, like, from this kind of 3D printing thing. Okay, so that we have did. Uh, for our lab also, like, we have some this kind of thing, but it is on the, like, not in but currently with me. Maybe next time I will find and I'll show you. uh yeah, so these are the gifting thing of, like, based on the application we can do. Then then another is another important, what you can say, uh, additive manufacturing process, which are more popular in industrial applications, are SLA based. Okay, so what is there? With the help of laser, the resin tank, there's a resin tank, and the resins are solidified with the help of laser. Okay, so it is one of the thing. Okay, so this kind of structures are basically printed with the help of SLA. Okay, and the typical structures which are not like uh, prominently printed by FDM, we can easily print with this SLA process. Okay, so here is a video of like, just for, you have already seen, maybe some of you have seen the additive manufacturing process, but I am showing you one of the video that is very in a fast forward manner. It is there on the YouTube. I have selected it from YouTube only. So the printing of this particular structure. So you can find this kind of printer there. Okay. So it is a fast forward video. So this is the actual speed on which it printed. So this is the board. Okay. Uh, and this is the material coil. Okay, where metal is there, and the nozzle is printing it. Okay. And sometime what happened, like, if the part is not like, because there is a certain just see the video. Just okay. So So you can like DIY activities are now very much popular. So people used to purchase this kind of printers for their DIY activities, right? So this is a very now these activities are very common. So what happened? Like what I'm saying, ki sometimes the parts are very larger in terms of like out of capacity of the machine, that particular 3D printer. So we have to build the part in different build the build the component in different parts, and then we have to assemble it. So like this also, the half part was printed separately, and another head was printed separately, and then it was what you can say, pasted or with the help of some glue or something like that.
Sir, the
Okay.
best part or a surprising part in this was that if you see the way he has printed his head,
Hmm.
so he didn't, despite this, he didn't require a support. Like it
Support,
is
yeah.
going from neck to head,
Neck.
like it is reverse, na.
Yeah,
So,
yeah.
but still, it, I think, at least in the video, he hasn't shown AD support.
Yeah. So
It's-
no, so it is like not sub like this. What I can say, the printer, the company, those who are manufacturing this printer, na. So they are going to like they are researching for optimization of this support material. Okay. So one idea that like Muskan said, ki use the same material in a that chorus manner. Okay. Another was ki remove that support material and make the nozzle deposit the material in such a way that it does not require any support material. So,
Okay.
so
Okay.
this kind of structure, you can see this kind of structure will be printed without support material. Okay,
Hmm.
how? Just like
Reverse.
uh, like changing orientation is another thing, but if you very minutely increase the width, okay,
Okay.
so
Overhang. Overhang.
overhanging. So the overhanging, what you can say, deviation or thing, if it is very small,
Small.
okay, so it
Hmm.
will not require that support material at all.
Great.
Okay,
Great.
so this kind of optimization that companies are like this 3D manufacturer, 3D printer manufacturers are doing and encompassing in their printers.
Great. Great.
Okay, so yeah, so this was all that I missed last time because of the technical glitches, and then I thought we used to. I have to show it this week, and but yeah, this week again, the two lectures for the demonstration only of the 3D printer, so you can get more insight from there. Okay, so it is the recording of the 3D printer and the demonstration in the laboratory of IIT Kanpur. So you just visit and you just watch those videos. Okay, those two demonstrations. Then yeah, moving to the our next part. So now we are going to cover week number 10. Okay, so yes, week number 10. So course content of week 10 we are covering, and the course content was basically based on the plant layout. Okay, so in this week, layout of the plant has been discussed. Okay, so first the screen, just
Next plant layout study necessary.
yes, so the question says like which of the following factors make a plant layout study necessary? So design changes, expansion of enterprises, variation in the size of the department,
D.
all of these.
D. D.
D. Yeah, so this plant layout is very necessary if you're setting up any of the new firm or anything. So you just make a comprehensive plant layout so that if there is any further changes, like you will today you will start with manufacturing one component. Later on, you will shift to another one, or maybe you want to produce similar component, or you want to upgrade your product. Okay, so there will be design changes and all. So your plant layout must accommodate all those design changes. Then expansion of the enterprises, like today you are starting with a base amount of maybe 1 crore. Maybe after gaining much amount, you after 5 or 10 years, you will just you want to invest more to your enterprise and expand your enterprise in terms of capacity. So this plant layout will be like that only, so that it can be expanded. Okay, and then variation in the size of department. So suppose today you're you're what you are doing, you are importing the components from China or some other countries, and then fabricating it. Okay, and then later on what you will do, you will you will manufacture your component here only, and then you will you will assemble it and sell it. So you'll require the variation in the size of the department. So initially the assembly department was much larger. Now you also required a manufacturing section to be enlarged. And so for these kind of changes, to accommodating this kind of changes, this plant layout are very necessary. Okay, so answer is all of these only. Next question, two is there. A plant layout design is affected by processing time, product physical characteristics, in intricacy of the product, or all of these. So, what are the factors which affects the plant layout design? Yes, so again, the answer will be all of these. Okay, so obviously the plant layout is always affected by the processing time of the product, then physical characteristics of the product, and the intricacy of the product. So all these factors are the affects the plant layout design. Next question is a true or false type question. So it says like functional layout gives the firm the flexibility expected to deal with an assortment of the routes and process prerequisite. Is it a true statement or a false statement? Yes, so it is a true statement. So functional layout is only built for meant for giving the flexibility to inside the firm in terms of like process of the routes and the of the production of the that particular product. Okay, so this is a true statement only. Next question number four, it says what are or is the disadvantages of a process layout? So if you have a process layout, what are the disadvantages? So before this process layout, like there are certain kind of is the process layout is a one of the type of layout which are followed or which can be followed in the industry. So like based on the process, based on the what I can say, there are three kind of layouts. Okay, so that layouts are process or functional layout, so both are similar. Then product or line layout. Okay, so in process or functional layout, what is there? So like there is a factory shop floor. Okay, and certain kind of processes are uh, clouded. Okay, so suppose there is a one part where there is operation of drilling is there. Okay, at another part there is operation of cutting or like milling is there. Another there is a turning operation is going on, and another part there is operation of this assembly operation is going on. Another there is a section for inspection of the produced component. Okay, and so this kind of layout is a process or functional layout. Okay, so the functional according to the functions, the areas are separately divided. Okay, the particular the layout is prepared in such a manner. Okay, then next is the that process sorry, this product or line layout. Okay, so suppose in any firm there's a particular product which are getting produced. Okay, so the layout, the positioning of the machines are in such a manner that the product should get like raw material should enter from one side at one end of the that layout, or at one end, and then step by step it moves to the it move forward, and at the last it we get the final product. So it is the product on line layout. Okay, then we also have some what I can say this hybrid layouts. Okay, so in hybrid layouts, what happened? So like combination of certain layouts are there. Okay, meanwhile there is fixed position layout also. Okay, so the fixed position layouts are like for building bigger structures. Okay, so like if you are building some bridge or some buildings. Okay, so what happened, the all the components are arranged like in that particular area. Okay, and then once the component is built, again it is removed. So this kind of is the fixed position layout. Okay, and then hybrid, any kind of thing that can be used, combination of that. Okay, and then recently there is a newer kind of technique is there, that layout. Okay, so there's a rotatory kind of thing. Okay, to process based on the like requirement. It is in the same loop. Okay, and based on the requirement, the raw material is processed at different layers, different places. So yeah, so general purpose machines in the process layout, line layout for special purpose machines. So the answer for this is, what are the disadvantage of process layout? So it is, yeah, it is a high in cost process, in process cost. Okay, so others are not there. All of these is so already cancelled. High machine usage rate and this.
Sir,
Hmm.
what is non-perplexity?
Okay.
Uh,
Um,
I I really don't know this.
yeah, yeah. Just it is also a new term. I just forgot to see about what is that.
No problem. No problem. No problem.
No, no, no. Just give me a minute. I'll see. I'll see on that. Okay, so it is like it is a measurement of how well is the overall efficiency of the that
Okay.
layout.
Ha
Okay,
ha. So
so it is,
efficiency in a way
yeah,
we can.
yeah, yeah. It is, so it is a perplexity is the like uh, efficiency, like higher efficiency means it is highly this perplexity. Okay, it is the layout is having higher perplexity. Okay, so non-perplexity means it is having lesser, what you can say.
Efficiency. Yeah.
Yeah.
Yeah. Yeah. Clear.
Now, yeah. So next is, moving to the next question. Question number 5. It says, there's fill in the blanks. Utilize a type of transport that moves yield along at a persistent rate with a goal that worker can perform operations on the item as it passed by. So there is the unpaged line, medium line, paged line, or none of this. So this is the type of another categorization of the layout, that process. Sorry, that product or line based layout. Okay. So in the product or line based layout, what I said, ki the raw material enter from one place, one end of the layout, and then once it exit from the final end, so there is a final product. So in between that, there are two kind of lines are there. One is unpaced, another is paced. So paced means it is already like programmed with the help of that mechanical structures, okay, or control lines. Like the component will be remain at that one station for 5 minutes, then it will move forward for another station for 5 minutes, then another move for 5 minutes. So this kind of thing is there in the paced one. Okay, so it is automatically taking the component from one end to another end. And meanwhile, when the component arrives at the particular station, the operators are supposed to complete his part of the task by doing all the operations there. Okay, this is the paced one, and then unpaced one is like it is like the component arrives at one station. Now operator will take his time, okay, to perform the task. Once the task is completed, then he will push it forward. Okay, so that is unpaced line. Okay, so the answer for this question is again paced line. Okay, so now question number uh, question number so question number 6 is on the screen. It says advantages are: low volume items are best created for line layout. Unit cost is low. Low level of work and hardware usage. All of these.
B.
So
Unit
yeah.
cost is low.
So for this line layout, low volume items are best created. No, it is not there because it is for only high volume. So this option is cut and this option is cut. eliminated. Then there are two options: unit low cost is low level of work and hardware usage. No, so like hardware and workers are like more employed in the line layout. Okay, so only low cost of the particular one item is there. Okay, so for this line layout are always preferred for mass manufacturing of the components. Question number 7. It says this type of layout is followed by a hospital.
So I think cellular, no?
No, no.
Oh,
So
sorry.
so it is like fixed position layout. Okay, so why fixed position layout? So suppose there is a patient who goes to the hospital. Okay, then there is some bed. Okay, which is having all the things, all the required things like uh, what you can say that uh, I don't know what that saline part that we used to give, and then oxygen kind of thing we used to
Uh-huh.
give, and then ECG monitoring system, and
Okay.
all this. Okay, and bed and everything is there at particular
Okay.
position. We just bring the human, that patient. Okay, so in manufacturing term we can see like we bring the raw material and we build it. Okay, at that particular position only. So similarly we bring the patient and we treat it, so it is a fixed layout position. Okay.
Okay. Clear.
So in cellular, what is there? Like all the lines are in a circle, but not circular, maybe like in a close
Common
vicinity.
similar machines in
Yeah.
similar
Uh,
groups.
no, so all the machines are in a group. Okay,
Uh-huh.
and if like there is a center table, you can say if like suppose on a dining table you are sitting. Okay,
Mm.
all the foods are there. You want to eat some food which is with some like people who say sitting front of you. You just
Mm.
rotate the table. You just get that. Okay, so this kind of
Mm.
thing is there.
Okay. Okay.
So yeah, so that is the cellular layout is there. Like the components are on the center, and then around it the operations are performed. So like
Mm.
suppose one operation is performed at particular point one, after then it is required to be performed at point three. So if it is the line base, so you have to skip that two and then you have to go. So it is like, but here what you can say, motion in for like it will be rotated in anti-clockwise and clockwise both, so it will be easier for that in cellular layout. Question number 8 is there. It says is a kind of design where machines are assembled by the procedure necessity for an arrangement of comparable things that require comparative handling.
See,
Huh. Yes, Muskan?
function layout.
So it is a cellular layout, just we discuss.
Okay.
Okay, so what is there
Yes,
like?
yes. It will be
Machines
easy
are,
to compare
yeah,
if we, just like the example you gave,
yeah,
we can rotate the table and
yeah. Both side you can rotate, right?
correct, correct.
So
Yeah, clear, clear.
question number 9. In cellular layout, processes are grouped into cells using a method known as,
Group technology.
obviously, so it is a very simple question. Right? So it is there in the group technology. Question number 10. It says is used frequently to improve efficiency of the product layout. Again, it is a very answer for this question is very simple.
Line balancing.
Yeah, obviously line balancing, because this is a technique. This is the only statistical technique where which tells us about which like how to manage the load of the particular line and the particular station. Okay, so the line balancing is very important. Okay, so line balancing, like you can there's a very broader study of line balancing people used to do, and there are lots of numericals there. Okay, in the like if you choose the course of optimization, if it is there, so their line balancing is one of the chapter only. Yeah, so these are all the questions that we have to discuss today. Uh, now, one question is it is asked this time. I just wanted to like it was not a very big deal. It was not a question, but here you have to understand. You guys are going for examination, and then solving the assignment, then you have to understand the thing. So he like is something Vijay Kumar. He just asked that assignment number 9, question number 10 have some problem. So he said that factory cost is the cost of material cost plus over this operation cost, labor cost, factory overhead, and something like that. But his answer is wrong. So the question was like this. Okay. So it says factory cost is material cost and this. Okay. He mark is true because yeah, it is true because it is covering all material cost, operation cost, labor cost, factory overhead. Okay. So factory cost is always the sum of like sum of material cost, operation cost, labor cost, factory overhead. So he marked true and but the answer was incorrect and it was accepted and the correct answer was false. Do you able to identify the thing why it is false? Or you guys have got the answer for this?
Because there is a minus in labor
Yes.
cost.
Correct, correct.
Yes. So this minus, there's a very small minus is there, but because of this small minus, one mark, like one number, he got one marks less. Okay. So in the examination only, final. Okay, okay, Nikhil, no issue. You can go. Yeah. So in the final examination, uh, just look at it. Okay, just keep in mind that these kind of mistakes you just do not do these kind of mistakes. Okay, these are minor mistakes which people used to do. So you have to read the question very carefully. Like we already discussed about not statement. So statements, if the statements are negative, then you have to think negative. Okay, so about the that particular, you have to read the statement with not. So answer will be like that only. So if you are like, if some properties are there, so if it is written which are not the property, so you have to find that which properties not belong to that. Okay, so this kind of questions may come. Okay. uh, yeah, so that's all for today. Now if you have any query, you can ask it to me. If you want to say, or if you have something, you can share it with me. Otherwise, you're feel free to leave this meeting. I will be here till 5 p.m. To answer the queries of the student who will be joining. And yeah, we'll meet again next week on next Saturday, same time, same meeting. Thank you.
Thank you so much, sir.
Thank you. So, so this is all for today. Now it's going to be 5, and yeah, thank you so much for joining this session, and we'll meet again in next on next Saturday to discuss the course content of week 11 on same time from 3 to 5 p.m. and on the same link. I'm closing the session for today. Thank you very much.